Welcome back. My name is David Dick, and I'm speaking to you from Grenfell campus of Memorial University in the sculpture studio. Today we're going to look at rasps and files and talk a little bit about all the different kinds and which uses and materials they would apply to. So we're going to start with rasps, as they are used commonly for plaster material. One of the common things that we use them for is after having made a mold of an object, we'll go around and clean up the outside of the mold and just take off any of these sharp edges and make everything nice. Now we can see this one is working on some dried plaster, and it's just cutting the plaster off very cleanly. If your plaster is a little bit wet, you might be in a little bit of a rush, has some due dates to meet, you can run into some situations where your plaster is sticking to the tool itself. In that case, what you want to do is just grab a wire brush or even just another sharp object, and you could pick that plaster out from in between the teeth before it gets really crispy and dried on and becomes difficult to use. I'm going to move from rasps into rifflers. A riffler is essentially just a small section of rasp shaped into a different form, and those can be useful for finer details, even getting into inside curves, cleaning up inside things. For example, if we had a bubble inside this mold and we wanted to clear that off and try and make it appear like it was never there, we could deal with that with a riffler. Moving on, we have a couple of different sizes of shear-form rasps, and these ones will take off large swaths of material on the flat much easier than any of these other profile tools would. These ones remove a lot of material and they eject the material to the inside, so you'll often just have a big pile of material and then you can dump that into the garbage or off to the side. Likewise, cleanup on those ones can be with wire brush and is much easier while the plaster is wet or soft. Right. So moving on, rasps can be a very useful tool for forming wood. You would want to leave it more towards the end of your forming than starting out with a square block of wood like I've got here. They don't remove a whole lot of material, but they can fine-tune the surface of the material, taking off any high points and leaving you with more of a smooth contour. This would probably be a more intermediary version, and then you would progress onto a finer sandpaper as you finished your piece, if you were looking for an ultimately smooth surface. So we'll move on to files that apply to metal work here. And we've got a number of different profiles here. So we just have a flat file, more of a mill file there, in a couple of different sizes. These are different from each other based on the spacing of their teeth. So we can see this one, which is not going to come through on the resolution of the camera, is kind of medium. This one's a little bit finer, and then these teeth are coarser. And they're going to remove more material per file than these other two, and it's going to leave a rougher finish as well. There's also a couple of different things. We can see that these teeth are cut on a bias, so they're not cut directly across at 90 degrees to the file. They're on about a 45-degree angle. And that can let you achieve different surface finishes. So I'm just clamping up a piece of steel in the vise here. If I file directly across, I'm removing a lot of material. It's giving me sort of a rough surface finish, whereas if I draw side to side, which should be called draw filing, I can get a little bit smoother. And that's also good for thin material as well, so I'm not dragging a rough surface of a material or a rough surface of the file over top of a thin piece of material and sort of making it vibrate or catch a lot. I can just use the sideways motion to keep everything smooth and keep everything clean in that sense. So the curved inside profile of this file can let me get to sort of different shapes that I might need to finish up there as well. And thinking of these files, on all of these ones, the edges are also file surface. So you could file something very narrow, you could file a slot into a piece of material, and so on. If you needed to get even finer than that, we have a set of jewelry files available, and they're pretty much the same thing that we see with the rest of these files, but on a smaller scale. So you can get very fine detail out of these, and some interesting different profiles, triangles, and so on. One thing with that, so I was filing on steel, if you get into different materials in the metal shop, such as aluminum, it can tend to gum up a file. So kind of a hack to get around that is to put a little bit of chalk on the file. That will fall into the inside of each of the teeth on the file and give a little bit of a surface to resist that aluminum clogging into there. So sometimes you might come across something like that that could help you in your work. These are found in the metal shop and the wood shop. This is commonly referred to as a power file, also a handheld belt sander. So it kind of crosses that line over into maybe a different powered tool or an idea of a sander. It does replicate in use sort of a powered version of a file in terms of removing material. Basically just an on-off switch. After it's attached to air, the switch will turn it off and on, and the belt will rotate around and will remove material as long as you're holding it up against the surface there. And the other one I've got here is a die grinder, and it's loaded up with a carbide bit. It's also referred to as a rotary file. It does have the same surface as a file, just spins around, so constantly removing material, and removes material to the profile of the bit as installed on the die grinder there. And that's about it for files. Thank you for watching this demo.